Well, hello, and welcome to another Building SaaS with Python and Django stream. I'm the streamer, Matt Lehman, and I'm a software engineer. I have a background in Python and Django, and I am planning to show you how to build applications using those languages and technologies. This stream is all about building software as a service, and just covers the ins and outs of how you do that, or how I think you can do that. There are many approaches. Mine is one of many, but I do think that I know a bit about this because I do this professionally, and I have something that I can share with you. So the goal is to teach and also work on a side project at the same time. But I'm more interested in answering questions and getting feedback from people and just having a good time streaming here. So I encourage you to use the chat room. In fact, I'm going to use it in a minute to encourage people to read the issue that we're going to look at tonight. And if you're on Twitter, share with people so that folks can find out about the stream, so that we can get more interaction going here. And with that, let's get started. So I have introduced this a few times. This is now my 8th or 9th streaming session that I've done specifically for this purpose, and I've introduced the product each time. It's a product called Conductor, and it's a software that's intended for independent educational consultants, and is designed to help students manage admissions deadlines and various things like that. The specifics of how that area works is not really that important for this stream. I don't expect you to become a college admissions professional to understand what's going on. We're going to spend most of our time in the code, but just know that that's the domain that we work in. And so the models that we deal with are schools and schedules and dates and that sort of stuff. So that's sort of the important thing. So tonight, we're going to return to a third-party integration that I've been working on for a little while. In previous streams, we did the model, and then we did the actual display of the data, but now we have to do some background work to actually get the data from the source. But before we even get there, I wanted to take a detour. And I took this detour last week and was looking to add a tool called Hupper, which I believe I have the documentation over here. Yeah. So Hupper is a pretty cool tool that I found when looking at the warehouse project, which is what the Python package index uses to run all its software, and how that website works. But their development stuff has this interesting utility tool called Hupper. And Hupper's job is, well, you can probably read the documentation here, but it's really designed to just watch your code and watch for any changes, and if there are any changes, restart whatever process that you give it. I don't know that if they give an example here or not. Yeah, they kind of do. It's down here. So last week I attempted to add Hupper to my system. So I run my development site using a what's known as a procfile. Procfile is a format that was popularized in the Ruby world, and with a tool specifically called Foreman. But it was brought over in another incarnation in Python using a tool called Handshake. And essentially what a procfile does is it tells you which processes you want to run all at once, and runs it in a single command so that you don't have to have multiple terminals and be starting up multiple things. So what I wanted to add Hupper for was the worker. And initially, with my earlier setup actually looked like this. So it was Celery worker, and you pass in all this information, and it starts up Celery. Celery is the background task processor in my application. So anytime there is work that needs to happen outside of a HTTP request and response, I have this background work to make that possible. When I was doing development and actually testing out the application and testing out these background tasks, Celery does not have a reload mechanism out of the box. So what I wanted to do was get a version that used Hupper like this to actually do that reloading automatically, so that anytime I change my code, I could then experiment with it using Celery. I was having some problems last week, and I just wanted to like close the loop and show that I did in fact get it working, and give credit to Hupper, because it is a solid tool, and I was down on it. Not really down, but I was just disappointed that I couldn't get it working last week. Figured out what the problem was. Turned out it wasn't actually Hupper's problem at all. The way Hupper works is it tries to use one of a variety of polling or monitoring pieces of software, either Watchmen, Watchdog, or a straight up polling mechanism. And these things are designed to look at a large set of files and watch them for modification, date changes, and then that's how they work. So the real source of the problem that I was experiencing last week is that Watchmen wasn't working. So if you go back and watch the previous week's video, which I post on YouTube on a playlist out there, you can follow along and you can watch us not get any output. And it turned out that Watchmen, for whatever reason, I didn't bother exploring it, just didn't work the way I wanted it to work. So I switched to this alternate monitoring mechanism of Watchdog. Watchdog is a Python package, which I've used in the past. It was pretty solid. And then just had to tell Hupper to use Watchdog instead of Watchmen, because it has an order of preference of which one it's gonna use. And so I need to tell it. So just to make sure you see how that works, I put in an environment file. It's this environment variable named Hupper default monitor, and you tell it which thing you want to use as the monitoring tool, in which case it's the Watchdog file monitor. And then in my requirements dev file, which I use to do my pip install for all my packages, I needed both Hupper, whoops, not HTTP, Hupper, and Watchdog. Okay, so that is how I ultimately got Celery doing reloading now. So now if I change, if I start up, work on Conductor to get my virtual environment going, and if I say honcho start, you can see that it is starting all three, the front end, the worker, and the web. Worker is what we care about. So that's message right here at the top, starting monitor for PID 9839. That is, where'd it go? That is a message from Hupper. So I did play around with it and confirm that yes, in fact, if I change any of my code, it will do what I want and it will reload Celery, which is great. So that's not really what we're focused on today, although it might come into play a little bit later if we're testing this out. The goal today is to look at a third-party integration. That's what I've been doing. And we're integrating with this service called Prompt. Prompt is a tool all about doing college essay stuff. And specifically, they have tools to help with writing essays and making better essays for college applications. So it's really a common tool used by students. And what they do that I really care about for College Conductor is this alternate page here that is essentially a list of a bunch of schools along with the essays that they have. So the flow that that I'm introducing into College Conductor is an IEC, an independent educational consultant, will log in, use the tool, bring up a school that they're interested in for their student, and in the process of doing their research, be able to click a link that will take them to the Prompt site, to this page, and show them here are the essays that they're going to need, that their student is going to have to write. That's the idea, to give some information to the consultant to do their job more efficiently. So I've got all of this code is up on GitHub under my account, mblayman/conductor. You're free to peruse it as you see fit. There's a lot of cool code in here, but I also try and use the issues of GitHub to sort of act as little mini specifications for the feature that I'm trying to work on. And so here is the details about the prompt integration broken down by what we really care about. And so the previous couple of streams, we've made a Django model. So College Conductor is all built with the Django web framework, which is a Python web framework. And we built a model, which is the interface into a relational database. And so that's going to store information about these prompt schools that will be the links that we can then use to get over to prompt. And then the thing we did last week was we took that information and we added that data into the page that will display the school for the consultant. So to give you an example, let's look at College Conductor, University of Virginia. So I'm not logged in right now, but if in the logged in view, it shows this data, and if the school connection was made and the data was available for prompt, it would show as well a link that says view prompt essays or something like that. And maybe it'd be better to show off the real thing or the real development version so that we can actually see that live. Come on now. Sorry. Okay, forget that. Let's come over here, HTTPS. We can just type. Okay, so now I'm on my local site rather than the main at the actual public thing. So this is just test data. Once I log in with my test account, we can get over to the school. We can look at schools, University of Virginia. And the slowness here is not Django. It's actually, I use a local HTTP, or excuse me, an SSL certificate. And for whatever reason, Firefox doesn't like the non-authenticated SSL certificate, so it takes a longer time to grind through that. So it actually is very speedy, but sometimes there's a slow page load, and that's because if you look in the corner, it says like negotiating Handshake. So it's all related to the SSL connection. But here's the link that we're going to. So we have a University of Virginia profile here. It's very minimal at the current moment. I'm planning to put more data in there in the future. But if you click into the view prompt essays, it opens a new tab and takes you right to University of Virginia and gets you all of the information. So that's the context of what's going on there. And I guess so people that have some frame of reference, let's paste some stuff in the chat room. Say we're working on this issue tonight. Ask any questions if you have them. So what are we doing so the data is already there, the model is already there to store the data, and the display is already there to show it off on the other side. But the piece that is missing is the actual collection of the data. So College Conductor has about 2,000 schools that are in it, and prompt has less than that by quite a bit. They have a lot of schools that are here, but the list is significantly shorter. So what we're going to do tonight, and I hope with not too much effort, is to go through this page and use Beautiful Soup, which is a web scraping tool, and essentially scrape this page for links and create data that we put into the College Conductor database that maps to the school. So give you an example, Quinnipiac University. What we're going to do is if we inspect the page here, right above this page or right near it somewhere, here it is. There's an, this is bolded and it has an anchor tag with an ID of Quinnipiac, and it has the text here of Quinnipiac University. So I want to take those two pieces of data, the name Quinnipiac University and the ID Quinnipiac, and I want to put them into College Conductor. And once that information is in College Conductor, I'll get however many hundreds there are here, and I'll be able to start connecting them to the 2,000 schools that College Conductor has. And that's going to be sort of a background administrative task that's going to require some manual review, which I think that we might be able to automate some of to make it a little bit faster. But the data on College Conductor is only really valuable once all of that extra stuff is there. So I think now, hopefully, you have a full idea of what's going on with this integration. If you don't, ask me questions and ask me to explain what I mean by something. I'm happy to stop, because I know I've had people come in here that have tons of experience with Python and others that are pretty new to Python, and so it may not be clear what we're doing, but that's hopefully the idea. The way we're going to go about this is by adding a task in a tool called Celery. So now we'll stop the server for now. It doesn't need to be running. And we can look at what a task is. So Celery is a background task worker. So when you have things that don't happen on a normal HTTP request, when someone's not hitting the URL, what do? How do you do that? The one way to do it, or a common way to do it, is have some kind of background worker that is reading from a queue of tasks that get added by other things. So I'll give you a good example of, let's say, your website that is generating some kind of PDF, like a receipt. And you know that generating PDFs is going to take a little bit of time, that you don't want to interrupt the user's experience. So in your user interface, you give them an option to generate a PDF, and maybe you use some Ajax to have a little spinner or something like that to give them an indication that something is happening. And in your web request, you send off a task to this queue that says, go generate the PDF receipt. And the workers that are listening to that queue will pull down the task, do the actual PDF generation, and then report some kind of status back. So you can then have your front end be polling for, has this PDF been generated yet? And as soon as it has been, you can finally then display it to the user. The nice part about that is the user doesn't get blocked by waiting for your entire page to load until a PDF is done. So it's really a strong technique for making your actual response back to the user as fast as possible. Because we know through lots of studies from Amazon, Google, all sorts of people, or companies I should say, that the faster you can go, the better the perceived value of an application or a service will be. So that's why we want to go that method. So we're going to use Celery to create a task that will do the actual web scraping, and the difference is it's not going to be triggered by an HTTP request. It's actually going to be triggered by a schedule. So, Celery has a separate tool that goes with it called Celery Beat that is managing a schedule. And actually, we can probably look at that and check out the existing Celery Beat schedule. Okay, so here's this block right here is the Celery Beat schedule. And if you're familiar with Cron, it can function kind of like Cron in a number of ways. You basically tell it which task you want to run, and you give it the frequency of when you want to run it. So I have another thing that's doing some other work called scanning for what's known as Common App schools, and that's happening over there. And it's happening every Sunday at 2 in the morning, UTC, and just so it doesn't run every minute for that morning, it's just specifying the 0th minute. So what we're going to do is we're going to add another entry into this schedule that will be something like prompt scan, prompt school scan, or something like that. And it will point to a task, and it will have a similar kind of cron tab entry of running once a week, early in the morning, just to verify that the page has not been modified, or if it has been modified, add new records to the database. So that's the goal. And in the task is where we're going to do the web scraping. So the first thing to do, I think, is to start the shell of the task. So let's go back to our previous file, and we can see the format of this stuff. So here's a simple task that exists already. You can see that it's a function, takes arguments, and it doesn't work, and just sort of ends and doesn't return anything. I think they can return results if you need to have tasks communicate with other tasks, but typically it's just a kind of a one and done sort of idea. So we're going to go over to a similar file that does not exist yet, actually, and create a task over there. So I'm trying to put all the integration code that I'm doing into a single Django application. So let's get some lingo down. Django, the entire website is referred to as a project. That's the thing at the top. And then underneath the project, you have multiple applications, and each application serves a different purpose. And applications can have their own database models and URLs and views that display data, and that's how they structure things so that it's not just one big mess of stuff. So when I say application, I'm not referring to the entire website. I'm actually referring to a Django thing, which is like a part of the project. So we have a Django application here, and applications, you can just follow a pretty common pattern of you'll find an admin file, an apps file, a models file, and a views file. If you are looking at somebody's Django project online somewhere, and you come into a directory that has these files in it with like the models, you're looking at a Django application. So conventionally, Celery uses a file name of tasks. So we're going to create a tasks file, and I'm going to cheat a little bit here. That's not really cheating, it's just taking advantage of what already exists. I already have good working patterns in this project, so I'm going to follow suit, and I'm going to get the Celery app, and we're going to create our task. And the way to do that is just by using a decorator called Celery app task, and let's see, we'll call this task scan prompt. I think that's simple enough. Scan prompt is not, I don't even think it's going to need any parameters, because we know the website URL. It's really not changing, or it will change once a year, and it's something that I will just come in here and modify when it does, because I'm trying to keep this fairly low tech for now, and if it becomes a bigger feature for our users in the future, I can do more, but I don't need to go crazy here. I use Python 3's type checking syntax, so if you're wondering what that arrow none is, that's what's going on there. And I want to say scan the prompt website for new schools with essays. That's the goal of what this function is going to do. So I think that's sort of a skeleton. Now, one thing we will probably want to do, I like to write unit tests. In fact, I have some. We can look at the planner test tasks. There should be one for this guy. Okay, and so there's a file that matches, that does some testing on this task. And so I believe in the value of unit tests. I think that they really are super helpful, because especially on a project like this where I'm the only person running this project at the moment, and if I didn't have a unit test to back me up, I wouldn't have nearly as much confidence that the site will continue to work the way I want it to. So by adding unit tests along the way, I give myself scaffolding to convince myself that things are okay. Unit tests are not Panacea, to use Cliche. They have there's ways you can mistest. There's still ways that bugs can get in, but if you write unit tests from the start, it's just an easy pattern to get into to help your code quality stay high. So we're going to do that. We're going to create a test file for this, and we conventionally use like a parallel naming scheme. So the file is called tasks, so that we're going to call this test tasks, and as well as keep them kind of side by side. So we need to import the test case class, which is where all of these things will derive from. And the reason for that is because I've added stuff to the test case, which it inherits from the unit test case class. Or no, that's not true. It inherits from the Django test case class. So it has all the built-in Django extra goodies that come in there, but I also add in extra testing tools onto that test case to make it easier to run my tests. So we need a test case that is going to be called test scan prompt, because I like to try to name my test case as something that matches the function or object name, and it's going to inherit from test case. So what is this going to test? Let's pause and think about that for a minute. Ultimately, I want to test that a web scrape of the prompt website will find a school and store that school into the college Conductor database. Okay, so that's minimally what it needs to do. So, whoops, it's not a function. We want this to be a class. Wondering why that was complaining at me. Now what are you complaining about? Okay. So the place this stuff gets stored is in model records. So we have to, the task is going to do the web scraping. It's going to look for all of those links and names and just kind of collect them all at once. And it will create the record if a record of that same parameter does not already exist. And if it does exist, it will just skip it and move on. Okay, we're gonna try and keep it pretty constrained to what it's doing. So what's a good test then? We want the test to test that it creates a prompt school. And the reason I called it a prompt school is that's the name of the model. So let's we can bring up the model. So here's the prompt school model. You can see it there. It doesn't have a lot in it. It's collecting a name and a slug. Slug is the, let's go back to our actual website. Let's talk about it. So in this format, this ID parameter is what I'm referring to as the slug. Slug is a unique name to get us to the right spot in this page. And then the name is then Quinnipiac University. So this is the two pieces that I'm going to put into the record. You'll notice that there's one more field on the prompt school model, and it's this school one-to-one field. And it starts out with null equal true. That's important. When this task creates records, it's not going to know what school to connect it to. And I'm not even going to try to put in the logic to try and figure it out automatically, because there's a pretty good chance it will fail, and it's just not worth the time. So that's where the manual effort will come in. So once the name and the slug are established, I can use the name to then see Quinnipiac University. Do I have an existing college conductor school that is a record for Quinnipiac University? As soon as I do, I can make a connection in the admin tooling that exists to connect the school to that prompt school. And once that connection exists, there will be enough information to then display that on the schools page. So then if you, and continuing Quinnipiac, if you went to Quinnipiac, that page, and it would have the view prompt school thing, and it would use the slug of capital Quinnipiac coming over here as this ID. And so it would fill in, just like this URL up here, of hash Quinnipiac. And that would take you to the Quinnipiac essays, of which apparently there's only one. So maybe Quinnipiac's not the best example, but the idea is the same for any of these schools. Let's look at what is read. Read has more examples, so they should be the same. Oh, this is going to be fascinating, because look at this. There's extra data. We're going to have an interesting time on our hands, because this is already showing that read is different from Quinnipiac. So this might not be an easy web scrape. We might miss some schools. Great. Good times. So here's a truth about web scraping. If you ever end up doing any of it, you'll find that the web is very inconsistent. And this is a perfect example of what looks like, I mean, you look at Quinnipiac University, you look at Reed College, they don't look any different, but the markup between them is different. There's stuff that exists in one, but not the other. Weird, but such is life. All right, so I think we have everything we need now to get going. And I'm going to use, I've done some web scraping. I'm not, so confession time, I don't do web scraping a lot. I know enough beautiful soup to be dangerous, and know roughly how it works. And I know very much know about HTML, so I know how to do that part. But I might fumble through some of the actual mechanical bits of setting up beautiful soup. And because of that, I'm going to rely on a previous task that I did to kind of remind myself what is the API for beautiful soup that I care about, and how to, just go about doing that. Okay, so let's bring up the other thing that the other task. Where is it? The other task that we have is over here. And so this does another school of this website. And yeah. So this one was even harder because it had to do a loop and it had to deal with pagination. The nice part about this page is it's really just a single page. Like there's no other pages to go to. So it really makes it kind of optimal for web scraping, because it's a perfect use case of there's one page, you have to get some data out of it, and you don't have to follow any links. So this other example that I had was something where it had to look for a pager, and a pager is like the thing that you see at the bottom of a page. It says, next page, last page, page 6, 7, whatever, that just groups things together. And this page, this particular website does not have that. So our job gets pretty easy of just one read and look through it and then process it, which is kind of cool. Okay, so we're going to need let's call it the prompt school URL. And that URL is this guy, minus Quinnipiac. Okay. So we'll do the web scraping tool that we have, Beautiful Soup, doesn't actually do web requests. So it has no idea how to get the data. So it's actually a 1-2 punch that we're going to apply. We're going to take the requests library, which is great at fetching data from the internet and doing GET requests, which will just go to that URL and pull down all the data. And then we'll take the data that we get from requests and pump it into Beautiful Soup. Okay. And so the thing to do now is import requests, because that's the first step in this process. And say the response that we want is from requests, and we want to get the prompt school URL, and we want to give it a timeout. I don't want, the reason you need to give stuff a timeout is a request by default will block forever. And that has some nice attributes if you know that a website is going to be reliable, or maybe unreliable is a better way to state it. And you want to just be patient and you have the time. But when you're running a system that you don't monitor in the strictest sense of that, you don't want things to just have unbounded time, because they can start to take up memory, they can cause problems with your infrastructure. So you always want to give constraints to what you're running. And the way to do that with a request is used to this timeout flag. And it's basically telling requests that, hey, if you're not done getting this data after 5 seconds, you better give up, because it's just not worth it. So I could probably make it larger than 5 because it's not a real priority if this site was taking a long time, like maybe they're down for maintenance. But it's the timeout that I used last time, and it's a reasonable value, so we're going to continue with it. And then we want to say response raise for status. This is a helper method that is just doing a check on the status code. So if you do a web request, every time you get a request back, the interface of HTTP, the way that the whole internet works, is through well-formed HTTP. And HTTP has a format that dictates like what goes into the request when you ask for stuff, but also what comes back. And one of the things that comes back is a status code, and the normal status code for a good request is the number 200 for, well, it's just part of the specification. It's just something you have to get used to. So that is a good message. And there's a number of them actually, but the typical GET request response is a 200. So this raise for status is saying if your status code that you get back is not one of these normal status codes, like a 200 response or maybe a 201 if you're doing a different kind of thing, throw an error. And that would be indicative that there was an error for fetching from the website. So it's kind of a safeguard to say, you know, we're really depending on the data coming back from the site, and it's not even worth continuing a web scrape if the website itself that we're fetching data from is failing. So that's why we're doing this. Okay, so that's sort of the basics of this. Now, over in the test, what we're going to do is we're going to import. So from Conductor vendor, we want to import tasks like that. And let's get this a documentation string that says the prompt school is found on page and created. Okay, that's what I like to write test documentation to act as like, this is the specification. This is not using the formal language of, you know, should and shall and like the kind of things that you might find in formal specification documents, because I think that gets verbose. But just make imperative statements, or not even imperative statements, just make strong statements about the desired state of the system. So this is clearly describing what this task will do. and what the outcome will be in the system. And some other people might write something like, the kind of stuff that drives me crazy is saying stuff like, test that the something does something. So you get extra words in there like test that. Well, you're already in a test case. You don't need to say extra stuff. So that's a little bit of ideology about how to write test documentation. But I follow the pattern of arrange, act, and assert. This is just a test style that is very, very clear of what's going on. As you have a group that does any test setup, and then you have the actual execution of what you care about doing, and then at the bottom you're going to prove that what happened, or that's not very well stated. Prove what you want to occur happened. So we want the page to be read and some information to get created out of that. So ultimately, the act is, this is where we replace this, where we're going to call tasks, and we're going to say scan prompt. And right now, there's more stuff happening in this decorator that we can ignore for when this runs as part of a Celery worker. But this also functions just as well as a regular function. You can just call it like a Python function, which is exactly what we're doing. So this is the action. And right now, if I run this test, it will literally go out and use the request module to call prompt school URL. And like we can say, well, let's just print, for the moment, let's print the response text. Okay, and let's say, just so we can be sure that we see it, we'll say self assert true false. Sometimes the test runner doesn't like to actually show output unless you have a failure condition. So I'm going to run this test, and it is slow. Why is it slow? Because it's actually going to the internet right now, and it's going to prompt. So there's a couple of things wrong with this. Like this is actually all the data from prompt. So what's wrong with doing this? Well, there is an argument that says that maybe as an integration test, which is kind of like a bigger scale test, you might actually want to try and talk to prompt to make sure that it's still working. But when you're writing unit tests are testing the unit, which is like the small singular thing. That's what it's trying to get at. That's why they call it unit test. And when you're focusing on a unit, you want to not be testing everything that's external to the unit. In this case, prompt, an external third-party service, is absolutely something unrelated to the core logic of what the unit is trying to accomplish. So that's bad. That means that if there's because what it could mean is if our test fails because prompt's website is down, is that because my code was bad? The likely answer is no. My code probably hasn't changed. It probably is related to like server maintenance on prompt. So it really does not have any business failing because prompt might not be available. So the way that we can make this work so that we don't get the penalization from prompt is to use mocking. Mocking is a way of replacing a component in a system with a fake version that will, not go to the internet, not make HTTP calls, not do whatever it is that's expensive that you're trying to do. So we're going to replace it with a fake version that will return some just pre-canned data, and that should be good enough for what we care about. So let's bring up the trackers test task file, because that one already has some of this mocking that we can use as a pattern for what we need to do. So we need to bring in something from the standard library. So in Python 3, the mock module was moved into the standard library. It used to be a third-party package if you were in Python 2, but you shouldn't be using Python 2 anymore, so it should be no big deal. So we have our mock is now imported, and what we want to do is we want to patch. Patch is just the verb that says replace the real thing with the fake thing. And we want to tell it what we're going to patch. And the important part is about where the patching happens. We're patching from this conductor vendor area, this tasks module specifically. So we're not trying to replace requests for the entire system. And the reason you don't want to do that is because you want to try and localize where mocking is happening. Because if you try and replace it like globally, what might happen is you could have interacting test cases that, you know, one is mocking at one thing, one's mocking at another, and they might not undo their mocking changes, so you start to get weird stuff that happens. So by saying we're only focused specifically on this vendor tasks file, we get down to the core of where we want to mock something so it doesn't have effects on the rest of our tests in the system. So we do that by specifying the module. So it's in conductor, vendor, tasks, requests. So now this import right here, requests, when this test case runs, will come back with nothing. So this should be a lot faster. Yeah. And why did that fail? Oh, right. So when you replace at the, when you add a mock to the class level here, so this decorator is added to the class rather than to function, it is going to add a parameter to every single one of your test functions in there. So we want to say mock requests. As a reminder, we're using type checking syntax, so we have to, and I've got it turned on so that it has to be there. So the thing that we're actually getting injected into the test function, test method, is a magic mock called mock requests. So now this should actually run pretty quickly. Okay, but you can see that the thing, let's look at this line right here. Before I had this print of the response from prompt, and look what's coming back now. So we replaced request with a mock, and a mock will just react with whatever you call it. It'll just pretend that it has that method, and it will say, sure, I've got that. And it will give you back this magic mocked object anytime you want that. So when we try and call text on this magic mock, it doesn't really know what that is. So it's printing it saying like, hey, this is phony data. So previously when it was actually like all that, just tons of HTML, now it's proving that we're not going out to the internet. And you can also see that's true based on, like, we ran that in 0.02 of a second. So clearly not having enough time to make the hundreds of milliseconds request out there and get the data. So that's good. That's a good place to be at, because the other part of that is that it gives us control over what we're going to do. So I'm going to follow this kind of pattern down here. Let's take a look what I did at this previous test. I took some data from this other website, and I put it in a like a test file as a snapshot of here's actual results that came back from this page. So what we're going to do similarly is create a data file that will have just a subset of the HTML, and like trim out everything except maybe like one school, okay? And by doing that, then in our test here, we can actually let Beautiful Soup do its thing, scan through the data, do our parsing, and assert that we really did find that one school, and it gets added to the database. So that's what our test is going to be. So we need to get the data. So ironically, I think what I want to do is turn off the mocking for a minute so that we'll actually get the data, and we'll store it in a file over here. And then we can then look at that file and just trim out stuff. So it's going to be, I maybe did this a little backwards, but it's okay. I'm just going to comment this stuff out. I'm going to have my editor complain at me that stuff is no longer there, but they can just deal with it. So coming over here, we want to take the text and we want to open it. So we want to open prompt results for writing, and we'll call it as just file. It doesn't really matter. We're going to delete this code in just a moment, and just say f.write response text. And we don't need to print it again. Okay, so we'll come back over here, and now I'm just using the test running as a way to actually just collect our test data. So who cares about the output? That wasn't really the point. If we come over here and look, you can see from our git status that prompt results is now a file that exists in our directory that we can go look at and pull out information about. So getting a little crowded, but we can close this for now. So there's a ton of junk in here, and we're not going to need most of it. I'm going to keep some of the structure, just kind of be representative of prompt, but most of it's not going to be really necessary. But what I want to do is come up a level and look in here and create a directory called data. And in here, I'm going to give it the same name, prompt results. I probably should just moved it, but whatever, it's okay. We'll go to the bottom. We'll paste it all in here. And so can close that guy. So this is our new file that's in our data directory. And we want to just kind of gut this file for most of its stuff, because gosh, it just is full of junk. So let's see if we can find one school and like nuke everything above it. Wow. Okay, I guess, and let's check the actual prompt website to make sure that we're getting a real school that's towards the end and not just something else. So it's kind of a sloppy process, you can see, but that's what web scraping is. It's not a clean process. Okay, so how about let's find Colorado State. Colorado. So here we go. This is really like the only thing that we really care about is this link right here, and the rest of this is just sort of junk. So I'm just going to go all the way to the end and nuke everything that is inside the body, and let's just search for the body tag like that and go to the end and get above Colorado State. Let's just include some other crap in there so the parsing is a little bit different. Nuke that, And okay, the rest of this is junk, but who cares? So it's got a, so now we have this like representative example of what the prompt data looks like. And in fact, we no longer need the top level prompt results file with all the data. So we can get rid of that. And we have, yep, that's exactly what we have. So let's go back to our tasks file and let's uncomment this and pull this back in. So now we're back to everything's cool. And we're going to take this same kind of pattern here where we're going to take all this stuff. Yeah. I'm going to put it in here. We're going to rename it. So let's just let's substitute common app and rename it as prompt. So we've got our prompt results path. So what is this code actually doing now? Let's just be clear. So this test is now, what it's going to do is look for the directory of this current file. So that would be vendor tests. And it's going to join it with a data name and prompt results, which will get us the proper path. And that's our path to the file. And then we're going to open the file for reading. That's what the read flag is there. And we're going to read the whole thing. And it's only like 60 lines. So it's a really small amount of data that we're going to read into memory and put into this prompt results variable. Okay. So then we take, we create a magic mock, which is going to be our response. And we set the text attribute to that to be the actual data. And this will start to make sense when we actually go back and look at the task. And then the final thing that we need to do is take mock requests and the get call, and you can modify the return value. And we want it to say that the return value is going to be the response object. Okay, so that's, and this section right here, this is our setup. This is what we call arrange in that pattern of arrange, act, assert. I think that is all the arranging that we need to do. So let's look at our, I need to bring in the OS module. Do that in a second. So I missed an import of OS. That's what it's complaining about. Okay. So we have this stuff that's set up here. The core of it is right here, this mock requests get return value. So this makes sense when you start to think about it, of mock requests over here is the same as this guy right here, requests. They've been patched when the test runs. And so when you say requests.get, you're actually asking mock requests.get. And notice they kind of change together. So saying, what is the return value of get? And we're telling it that the return value is going to be this mocked object called response. So response over here is going to be the same as this response, which is then, if you trace it back, has this text attribute, which is the prompt results. So if we delete this, and now let's just print, just to prove that we are sane. No HTTP connection is going on at all. We run our test, and there it is, which is all the junk that we had from before at the top. And then the Colorado State University is the one school that is actually in there that we're going to parse out. Hope that made sense. So that's the setup to get this going. So, and that gets the actual fetching down in a way that I feel confident that the test is doing what is actually happening with the fetching to prompt. And we have a small enough set that we're not churning on so much data or making a crazy test. We have just enough to prove out the assertion. And the assertion, as a reminder that that's what we're going to do. So the thing to do is assert that prompt school exists. In fact, why don't we go ahead and write the assertion so that you can see it first of all, and so that we can start working towards it, because the goal is to make the test pass. That's when we know that we've won. So we got to figure out a couple things. Let's go back to our prompt school in here for a minute and look at the Colorado state. So the thing that we're going to pull out that we're going to want as the slug is Colorado-state. And so what we ultimately want to be searching for is we want to check that the following is true, that the length of prompt school objects filter of slug of Colorado state, the count of that is equal to 1. Okay. Okay, I'm missing an import, so we need to actually import the model. So from Conductor vendor models, import prompt school. All right. So if we've gotten this far, and you know what, in fact, just to prove even a little bit more that we're really nailing the thing, let's also make sure that the name gets extracted as well properly. And this will just make sure that our filter is super tight, and that we're really going to get that our web scraping is doing the right thing. So let's say Colorado State University. Hopefully I've spelled all that right. Okay. So now we have our this is a full unit test that will test everything that we care about. Many would argue this is more than a unit test because we're going to be doing parsing, we're going to be interacting with a database, and to them I say, yeah, you're right, it's not strictly a unit test, but it is a reasonable unit to check, and so I'm calling it a valid test. So I like to have my arrange, act, and assert blocks separated by a new line, which gives you a very clear view of what is the setup, what is the actual thing that we're executing, and then prove that the thing that we executed does what we want it to. Hopefully you see that pattern. I know there's quite a few lines here to open this, and this is maybe atypical of a lot of my unit tests because most of them aren't dealing with web scraping. Like if we opened up, let's pick a planner views or something. If we look through here, oops, that's the actual views, not the tests. If we look through here, the tests here are vastly simpler. Like there's a little bit of setup, there's the acting right there, and then there's the one line of assertion. So most of the time I do try and follow a pattern of keeping a very tight loop for my tests, but for this scraping task, since it's such a messy endeavor anyway, I think it's okay to have like one task that just covers the majority of what's going to happen. Okay, so if we run this test, it should fail. because the test database gets wiped out every time. Let's delete that printing so we can actually see it. The test database is cleared between each test, so there's no data in here. So it tells you that that there's just no Colorado State University put in this thing. So this assertion makes perfect sense. The 1 does not equal 0 because, duh, we didn't find it. So now we have to actually do the work of the scanning. And so what we want to do is search for, what do we want to search for? Well, the first thing to do is to make the beautiful soup object. So regardless of what we're going to search for, we're going to need this no matter what. And this is, you have to tell Beautiful Soup that you're using HTML, because Beautiful Soup will also do XML and will it do other things? I don't remember. I think it's mostly HTML and XML, but you have to specify at least between those two. And on top of that, there are different parsers. So if you want to do a certain strictness of HTML, you can kind of up and down the strictness. So there's that. So we need to find in this chunk of code, or in this chunk of text from that Beautiful Soup is getting, we need to find all of the anchor tags, and then we only care about the ones that have IDs. So, all right, now here's where I start just needing to like look up stuff. Probably spelled that wrong. Yeah, I did. And doing documentation lookup is absolutely part of being a developer. So I mention this almost every week, but you know, you just got to get used to, you got to look at documentation sometimes, because that's the way that you interact with things. So I know that I used find all over here. Oops. And I'm guessing we'll want to do the same thing, but I don't remember. So this is the second attribute here, I believe, is a class. And I don't think that we want classes. So we want to do, I'm going to call it anchors, because, is that really what it is? Yeah. I want the anchor links. So we'll say soup find all, and just to start, let's just say the actual anchor tags, okay? And we will do for anchor in anchors. I don't even remember if our little chunk has more than just that Colorado State one. Let's see what happens if we print anchor. Whoops, I messed something up. Beautiful Soup is not defined. Right. Yes, of course it's not defined. Yeah, okay, BS4. I couldn't remember what the package name was. So now I have Beautiful Soup. So now we can run our test again. And okay, apparently there's only one anchor in there. In some way that's actually not a good thing, because we want to have, I don't want to pull in stuff, have like junk records get added to the database. But maybe before we sweat about that, let's maybe look up the API for find all and see if we can find a way to like filter it down to just include things that have an actual ID tag. Come on, find all, where are you? None of these are linking to it, so of course I have to, there it is. So find all takes a name. That's the actual A, the anchor tag. Here's the example of the title. It looks like when you pass it the second attribute is referring to the class. How do we get? So there are a couple ways that we can approach this, I think. There's one way that says we actually write the right find all command that will filter to just anchors with IDs. I'm almost in favor of taking the stupider approach and just saying, give me all of the anchors, and I'm just going to check for the ones that have IDs. And if it does have an ID, assume that it's a school, because that means it's an internal link onto that page, and that seems to be the only thing that is internally linking on the page. We're going to probably run into some corner cases where that's not true, but that should be pretty good. So we're going to find, yeah. So let's go onto this page. Let's go back to the prompt school. Where are you? And let's view the page source. And now I'm going to look for any links. Okay, so there are links in here that open to other things. So I'm going to grab one of them. Just one. I don't really care what. I just want one to put in our dummy data. And I'm kind of messing with the format a little bit, which is maybe not a great idea, but it's okay. So let's go to our prompt school prompt results file, and just let's put it above here, just paste in this thing. It doesn't really make a lot of sense where it is. It's not even in a paragraph, which bugs me enough that I'm going to put it in a paragraph. So now it's in a paragraph, and it's a mail to link for their support team. Okay, so now if we run this test again, it's going to print out, good, it printed out both links. So now I really can work from this to say, like, here's some data we want to ignore, here's the data that we want to keep, and that should be good enough. Coming back to the actual thing, we need to check how do we get the ID? I actually don't know. Let's guess. Let's just flat out guess. I'm gonna say anchor ID. See if that's smart enough or if that's something totally different. It could just be like the memory address and be totally wrong. Okay, not what I thought. So we need to find out how to get the right attributes of something of a tag. And okay, I'm going to continue to brute force this because sometimes it's just easier. I'm going to basically say, what are the things that are on the anchor? So anchor is like a thing that's coming back from Beautiful Soup. It's a kind of some kind of class object. Actually, we could probably even, while we're at it, let's just see. Let's educate ourselves about what is anchor. Anchor is a it's a tag. Okay. And when we do dir on anchor, it's just like kind of massaging the data and working with it. And something I love about Python is it's so introspective. You can get into it and explore it and kind of not fumble your way through it, but act in smart ways to like discover about it. I have a feeling what we care about is going to be in this adders thing. So let's print, this time let's print anchor adders. See what comes out from that. And we'll keep that dir around in case we need to look at, in case adders is wrong, we need to look at something else. Okay, so looks like adders is a dictionary, and the dictionary has an ID if it's in there. Perfect. So we want to say our filter that we want to put on this is if ID in anchor adders. Or, you know, better yet, let's make this a guard clause. A guard clause is kind of, you test the negative and you bail out if that's wrong. So let's say if the ID is not in adders, then we want to continue. And that continue just means, here it means continue to the next iteration of the loop. It doesn't mean continue through the bottom if you're fairly new to programming. So now if we print the anchor, the only one that should be coming out is Colorado State University. Good. Okay. So we have ID in adders, and we know, let's go ahead and extract it as the variable that we want to call it. It's the way that I define the model is I called it a slug, because that's gonna be the thing that will go into the URL when we're actually linking to the page. Sorry, I'm starting to lose my train of thought. I probably needed to wrap up here soon because my brain is slowing down. It's getting late. But we want to say, we know that ID is in adders at this point, so we want to say anchor adders and pull out ID, and that's our slug. And just one more time for making sure we're getting it all. Colorado State. Okay. So the next thing we need, let's go back and look at prompt results. Colorado State is here. So I am going to make the assumption that prompt school, the site, has kind of a well-formed structure that after the anchor tag is the university name. That might not be valid, as we saw from read earlier, that there's at least stuff before it, but it did appear that Reed College appeared like right after the anchor tag. So I'm going to hope that that is correct, and we'll see the, so what do we need to do then? I think what we need to do is find like siblings. So I don't know what the API would be called for, well, there's a next sibling going sideways. So let's see what next sibling is to the anchor. Print anchor next sibling. Come on, Matt. Oh, that's just too easy. Too good to be true. Well, I'm going for it. So I'm not, this is a, like I said, I'm trying to make this work as efficiently as I can, like get this whole, you know, if I can get the whole feature done in an hour and a half and not spend too much time on it, because this is a back-end processing, and it's not really adding value to the product except to say like get the data out so that it can be processed. And so what's going to happen with this is once this thing is even done, we're going to what are we going to do? We're going to like get a raw dump of the data at some point. Like I will when this thing runs. I'm going to find out if I was wrong in my assumptions about it, or if the data turns out to be very well formed, and every time there's an anchor link, the school name was immediately following it. That'll be super useful to know. And if I'm wrong, I just dump the stuff that's wrong and refine and do it again. So it's kind of an iterative approach and using as little as effort as possible. So what I'm going to do is I'm going to say, we already have that established that next sibling is the name of the school. So now we have these two parameters, but we still haven't even made the record yet. So I'm going to bring in our model. So we're going to bring in from conductor, vendor models. We want to import the actual school model that we care about. And we're nearly there. We want to say prompt school objects create slug name. So now our test should pass, I think. And it does. Great. Okay. I don't think we're done yet though. So this was like the very minimal version of getting this thing working. But we have to think a little bit beyond that first run. So if, and I don't think I even set a unique on this particular model, maybe I should do that too, but what I'm getting at is, let's imagine week 1, this runs. And it pulls out however many hundreds of schools are on this website. And we get all of these records created in my live site. And it creates hundreds of these schools that I'm supposed to process and connect to Conductor schools and get all that stuff. That's great. But recall that this stuff will run on a schedule. It will run every week. And so what I want to do is essentially not create something if the record already exists, right? So let's write that test. That's the other scenario that I really want to consider. Is so let's see, test skip existing prompt school. That's really what we're going for. And it's all the same stuff as the other one. Magic mock. None. And so the string for this one is skip creating a prompt school if one already exists. Okay. So how can I go about doing this? This is where I'm going to follow the same pattern as above. And so we're going to be less specific about the name this time. So we're really just going to care about the slug. And in fact, I want to use, we're going to reuse this slug name. So I want to use Colorado State up here. And we'll change this here to be slug. Okay. So this test is almost the same test as the one above. So this should still pass. Okay, let's make it fail. The way to make it fail is we're going to create a prompt school. So I have a factory class that can actually make fake data in the database. So I'm going to go ahead and create one that has a matching slug. Okay. So now this test should fail because going in as part of the arrangement for this test, we're adding a new school that has this data. And then we're also going to parse the same data from before and scan that stuff and create another record. And because we haven't come over here and modified this code to protect against that condition, this will actually fail. What we should see is 1 and 2. Let's see if we're right. Let's see if I'm right. Oops. Ah, cool. Even better. So it failed for a reason that I wasn't sure that I had done, but it looks like I have. Okay, cool. The reason is right here. So I said that all the slugs must be unique. So I'm adding a constraint at the database level, and this is protecting me from myself. So it's like, imagine that I had not considered the scenario where the task was going to run again in the next week, but I had thought to make this uniqueness case true. So the database is going to protect me, because the next time, so if I ran this thing once and it pulled out all the schools and created all the records and had all these slugs in there, and that's great, that's what we want. The second time that this ran, it would try to create the school with the same slug name, and the database is going to say, no, 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 you can't do that, it's not unique, and the whole task would fail with an exception, which is exactly what happened in this thing up here. So what do we do about that? There are a couple of ways to approach this. There is we can, sorry, I'm trying to think of both options in my head. I should talk out loud so you know what I'm thinking about. One is to do an existence check. That's the easier solution. So we could say, and I could write this version up very quickly. So if not prompt school objects filter slug equals slug exists, then create this. Okay, this test should now pass. So this is the easiest version, and maybe that's the simplest way to do this. But how else could you do this? You could also use a method, and I got this. I tried to use this previously, and I think I got it wrong. Let's see if there are examples. Get or create. No, how about, was it update or create? I might have just said no. Let's forget it. Well, anyway, Django has an API called get or create, or update or create, which is pretty cool. It does kind of what it sounds like, where this is essentially what it's trying to do. If you can read this chunk of code right here, it is trying to get this thing. The update or create method is trying to get a record if it exists, and then for anything that you want to update about it, make the updates and then save it. But if the record doesn't exist at all, it gets all the stuff and creates a new one. Okay, so this over here is like, if we're scanning through this and we wanted to change this so that it would do the updates of these things, like update the name or something like that. If a record already existed, we could do that. I don't really care that much. I only really care about the slug and then ultimately the connection to college conductor school. So I think I'm happy with this version. So what this version was saying, if it wasn't clear, is look through all of the existing prompt school objects in the database and filter them down to the slug that matches this slug. And if you exist, well, really, if you don't exist because there's a negation with a not here, then go ahead and create one. So that's why this test passed. So now if we run this whole file, both tests should pass, because in the first case, the record didn't exist. In the second case, the record did exist, and it just didn't do anything. So it was doing a query for the original record. All right, so we're almost done. I think I want to like close it off so that you see how it all hooks in. So we have our scan prompt thing now, and we're going to go back to that base settings file. Let's get, I think we're so done that I'm going to run the whole suite just really quickly. We haven't messed with anything else. Everything else is good. And we have this thing right here. So we need to define a new one of these. So let's call this, there's no reason to be cute with naming. It's going to be basically the same thing as above here, but we're going to change this. This is in the vendor app, and it was called scan prompt. And I don't want it to run at the exact same time as the other task, but I don't really care too much. So I'm just going to bump it by an hour. I'm going to save that. And oh, I forgot a comma, so it didn't like that. So I've saved it, and now we have this thing integrated. It's possible to test this, but what did I miss? I missed something. Here's what I missed. Let's look at the trackers for a comparison. Yeah, I missed a bunch of stuff. Okay, well, rats. I'm trying to think if I care enough to do something about this right now. So the piece that's missing right now is any sort of reporting. This is going to run, but run very silently. I won't get any email about what ran, and I will not know if it ran successfully or not, so that's kind of a bummer. This other one I cared about more because it's closer to the domain of what I'm trying to solve, so I made a whole report back for it. I think I'm just going to say forget it. So this thing will just run silently, and it will either work or I'll get an exception, and my error monitoring service will raise the error that there was a problem. So I'm going to leave it as is. But just know that the way that I could have closed this off as as an administrator for someone who needs to manage this, I could have sent out this report to myself to say, like, here's the stuff that has been added since you last did this. But I'm not going to. So I think that really brings us to the end of the feature. Let's go back and look at our ticket. No. It finishes this one for sure. But I also want to mention prompt on our landing page. So we're going to have to save that. So that's enough covering enough code for tonight. If you were here and listening, I really appreciate you being here. Even though there are no questions, that's cool. Some nights are like that. If you do have questions in the future and you want to ask me, or you felt uncomfortable asking me, I'm around on Twitter. You can message me there. I'm MB Layman, same username as here that I am on GitHub, or that I am on Twitch. So I kind of keep the same username. So happy to answer questions. I will put this recording up on YouTube so that you can refer back to it if you need to, and figure out what was valuable to you. And if you thought this was useful, I'd love if you could share out on Twitter that or whatever social media you're on, so that I can find other people who are also interested in joining and get a really good dialogue going. Well, let's see. I'm trying to think if I will be around next week. I don't actually know. I should have looked at the calendar in advance. No, I will be coming back from a different state. So we will skip the stream next week, and we will skip the stream the following week because I will be running the local Python user group. But so it looks like the next time I will be streaming is on January the 16th. And if I change my mind and decide to run on the 2nd, I will update the Twitch stream accordingly, because I try and leave a banner of when my next stream is. But that's the plan. I'm always open to feedback, so if anybody has any, happy to hear it. but yeah, this really concludes the stream for the evening. So thank you for tuning in, and I'll see you next time. Take care.